Okay, so today's lesson is Electricity 6 Ohm's Law simulation. We want you to really be able to understand and describe Ohm's Law and the relationship between current, voltage, and resistance. So hopefully you've already done your bell ringer. This video is really a great video. The whole channel has a lot of really good stuff, but the simulation is what you're going to be turning in today. So let's kind of open that and consider what we're all going to do. I've already got mine opened in Kami right here. You can use DocHub. You can put it on paper. You can print it out, whatever makes life easier for you. But we're going to go through that together, and I'll just document it on Kami for you to be able to see that. So let's look at what the question. Let's look at the simulation first, and then we'll look at what the questions say. So in the simulation, we have Ohm's law. Voltage equals current times resistance. We can, in the simulation, we can, I'm going to turn the volume off real quick for that. In the simulation, we can change voltage. We can change resistance. Notice we have no control over current. So when we change resistance, the size of the current, right here, the orange eye changes. When we change voltage, the size of the eye changes. And so that is dependent on these other two things. And we might notice we have current here. We have these little batteries. Okay, we'll get into all those things with the questions. Let's go ahead and look at the questions to get started. We have defined the direction of electron flow. Well, there's these giant arrows here, and they're the same color as current. So, and they change the same as current. So the current is the flow of electrons. This must be the current. So let's see, that would be in a clockwise pattern. So we are just going to write clockwise. We're going to go back to our text box, and we're going to write clockwise. Probably should put that in a sentence, but we'll move on from there. Define positive and negative terminals of the battery. Well, I know what a battery looks like. Usually a little nubby end's the positive, but let's really think about this. If the electrons are flowing this way in a clockwise fashion, then they are attracted to this end. So this must be the positive end, and that must be the negative end because they are pushed away from the negative end. And that's a really important part of this electricity is that electrons are attracted to positive charge. So instead of trying to describe it, we're just going to put that. Electrons, move my big old cursor. Electrons are attracted to the positive end. And that's all we have to put for my purposes anyways. All right, what do the black dots within the wire represent? Well, my first thought would be electrons, but let's find out. When I look at this, they don't seem to move at all. Change voltage, nothing changes with the black dots right here in the wire. But I change resistance and I get a lot more black dots. So those black dots must be the resistance of the wire. So we're going to actually write a sentence this time. Black dots are the resistance. We won't make any Star Wars puns. I'll let you do that on your own. All right, so then we have this data table. So many things on the data table. I'm going to go through this first section with you, and then we'll move on to the questions at the end. You'll be responsible for doing the other part all by yourself. So we have standard voltages, and we have a resistance. Let's set up our simulation. We need a resistance of 800 ohms. Oops, that's too much. So this thing is a little touchy to try to get it exactly on 800. Should have stayed with 801. Okay, well, that's 801. Okay, we'll stick with that. And then we needed to have 0.1 volts. So, that's nice. That's the very end. And my resistance is huge. My volts is kind of small. My current is really small. 0.1 milliamps. 0.1 milliamps. All right, so we're going to go ahead and type that now. That 36 is way too big to fit in this little box. So we're going to say 0.1 milliamps. Now, we need to kind of remember milli is 1,000. So let's bring up our paper, our sketch paper, scratch paper here, and we're going to look at what we have. Bring my microphone with me. We have 0.1 milliamps. I want that to be regular amps. So I'm going to say milli to regular. So 1 amp is 1,000 milliamps. So I'm going to say, all right, if this is regular amps, I'm not going to make a mistake on my math in a video. So let's make sure we pull it up and say 0.1 divided by 1,000 equals. Okay, so you guys probably could have done this in your head, but we like to go through all the steps of the math. So we're going to go ahead and type that, and we can remember for the other ones that we just need to move the decimal point to the left 3 times for later. Okay, so let's go ahead and type that into our box here. Okay. So then we're going to change the volts to 2 volts. 2 volts, and we have 2.5 milliamps. And eventually we will probably just write the amps, but we're going to move that decimal point 3 times. So we're going to say 0.0025 amps, because we really want to use amps in our equation. And let's just go ahead and get these done. 3.7. So 0.0037 amps. We're just changing the volts, and I forgot. Maybe about 4 and 5. Makes sense, right? At 4, we have 5 milliamps. So we're going to say 0.005 amps. Notice that the amps are going up, so our current is increasing as our volts continue to increase. A little touchy to try to get it right out there, and you can just be close if you need to. But we have 6.2 milliamps, so we're going to continue just moving that decimal point instead of doing all that. And then the last one on the list, and I'm going to move this up just a little so we get it back in our lines. Last one on our list is 9 volts. So if we go up to 9 volts, our amperage is 11.2. So 1, 2, 3, we're just going to have 1, 0, 0.012 amps. Okay, so you can see that you're just going to change your voltage, set your resistance and change your voltage, and then write down the current for these. And you're expected to do all of this part by yourself. And then it says to graph your data below. Plot the voltage as the coordinate y-axis and the current as the x-axis. That's a lot of work. I get that. We're going to skip that part. Okay. What kind of relationship did we obtain? Well, we can see that from what we have. As voltage increases, current also increases. Our resistance stayed the same. So that's what we're going to type. And we can make it a little bigger so we can see better on the video. As voltage increases, current also increases. That's the relationship that we really see. Now it says calculate the slope if possible. I know, slope is a math term. I'll give you a second. We're going to calculate the slope of our first one here. And we're going to see a little bit of math magic, but don't quote me on that. I know, no one would actually say math magic out loud in public, but that's okay. Let's talk about slope for just a second. Slope is a lot of things. Slope is the m and y equals mx plus b. Slope is y2 minus y1 over x2 minus x1. So in our problem, the question told us that voltage was going to be the y. So I'm going to type this so that I don't forget. And the current was going to be my x. That'll help me remember as we talk about slope a little bit. And I'm just going to do the last one and the second to last because those numbers are better for me. The y is going to be 9 minus 2 volts. Make sure you have our units. And 0.0112 amps minus 0.0025 amps. And so when we do this, we know we have 7 volts over, well, let's do this math on a calculator. We're going to have 0.0112 minus 0.0025 equals, okay, 0.0087 amps. Okay, so we still have a little bit more math to do. Let's go ahead with that. 7 divided by 0.0087 equals, look what we did, math magic. Our answer is 804.6, and volts over amps is ohms. So what we did was we calculated the resistance. So the slope of the line that is created by this graph is the resistance, okay, that each of them will have. So on number 7, we need to say, we could say that 804 is the slope of the first line. Okay, let's look at the other questions because I told you you could skip that. What is the physical meaning of the slope of the current voltage graph? It's asking you to interpret the graph. The slope of this line equals the resistance of the circuit. Okay. Slope equals resistance. Slope equals resistance. Is it possible to decrease the resistance of the wire without changing the material it is made of? What do you think for that? I want you to go to Google and search that, research it, find out what you think, and answer that question with a real life sentence. And then that is it. So you will be downloading. So you will download after you get all that done with annotations, and then you will submit that PDF to the Canvas page. And hit with the annotations, hit begin export. Don't forget that stuff. And then you will turn in that PDF to this assignment. And then please work on CK12 for just a little bit.